Okay, let's talk about variation. Our topic is variation. Okay, so now we're going to start off with an illustration. So imagine you go into a shop and you want to buy bread, right? So you go into a shop and you're going in to buy bread. Now, what do you know? If you increase, right, the number of loaves you buy, the amount you have to pay also increases, right? If you reduce or decrease the number of loaves of bread that you take, the amount you have to pay also decreases. So what are we seeing here? There's a relationship between our number of loaves, which I'm going to call n, and the amount that you have to pay, right, which I'm going to call a, such that if I increase n, a also increases. If I decrease n, a also decreases, right? So this sort of relationship is known as direct variation. Okay, direct variation. Direct variation is a relationship between two variables such that if you increase one, the other one increases, and if you decrease one, the other one also decreases, right? So that's what we call direct variation. So we can write the relationship between these two. We can write n varies directly as a. Okay, we can summarize the relationship with this statement: n varies directly as a, meaning that direct variation is a relationship that exists between n and a. Now this is mathematics, so we can shorten this whole thing by using the variation sign. So you can write n and put this here, which is an alpha, Greek letter alpha, and then write your a. This is a variation sign, so this statement is still the same statement. N varies directly as a. N varies directly as a. Now what happens, this variation sign can be replaced by an equal sign and a constant. Okay, this variation sign can be replaced by two things: an equal sign and a constant, right? So instead of writing n and the variation sign a, I can write n equals constant times a. So I can write n is equal to k times a there. Okay, so now k is a constant, right? Now remember, I called n and a variables. Now variables are quantities whose value can change, right? Their value can change. When I'm in a shop, I can change the number of loaves I can buy. I can change that. It can be 2, 3, 4, 5. The number can change. I can change the amount that I'm going to pay by changing the number of loaves, right? But I cannot change perhaps the price per loaf. If I walk in a shop, right, if the price is $1 per loaf of bread, I can't change that. So that's a constant. So that's something constant. Constant means unchanging. So that's something that doesn't change in the relationship. So n will be equal to some constant value times a, right? N and a can change, but k remains the same. So when you're really, if you're asked to find the relationship, right, between two variables, right, perhaps x and y, you need to have x is equal to ky. This is direct variation. But your k, you must find its actual value. You must find its actual value. So if k is 3, x is equal to 3y, that's the relationship you're looking for. So let's have an example here to show the whole process. So for example, we can say x varies directly as y. X is equal to 20 when y is equal to 4. A, find the relationship between x and y. B, find x when y is equal to 3. Okay, so what do we know? X varies directly as y, so we can write that in our solution, right? X varies directly as y, but we can remove the variation sign, put an equal sign and a constant, right? Now, for me to actually find the relationship, I need the actual numerical value of the constant. So how do I do that? I substitute the given values of x and y. What values was I given? I'm told x is 20 when y is 4. So I'll substitute for 20 for x and 4 for y. So 20 is equal to k times 4, right? To find k, divide both sides by 4. I'll get 5 is equal to k. So now I found my actual value of k. Once I found my actual value of k, I can rewrite this statement here with the true value of k. X is equal to 5y. So that's the relationship. That's the relationship. Once you find your relationship, you can use your relationship to answer the questions that follow. So before I even answer the next question, I'll quote my relationship. X is equal to 5y. And then the question is find x when y is 3. So instead of y, I substitute and put a 3. So where there was y, remove y, put a 3. So x is equal to 5 times 3. X is equal to 15. Okay. So now let's have another example from top to bottom. So example, P varies directly as T, P is equal to 30 when T is equal to 15. A, find the relationship between P and T. B, find P when T is equal to 4. Okay, so let's go through that. Our solution is simple. We know that P varies directly as T. Therefore, P is equal to KT, where K is our constant. Now, any letter can be used for your constant, but we're using K, right, for these examples. So don't be surprised if you come across situations where they don't use K, but they use another letter for constant. That's still fine. So now, the next thing is to find the value for our K by substituting the values of P and T there. We're told that P is 30 when T is 15. So I have 30 is equal to K times 15. Divide both sides by 15. I'll get 2 is equal to K. Once I know my K, I come back up here, substitute my actual value for K there. So P is equal to 2T. That gives me my relationship. Once I have my relationship, I can use it to answer the questions that follow. P is equal to 2T, so I quote it first. And when P is equal to 2T, I'm asked to find P when T is equal to 4. So I come back up here. When T is equal to 4, I remove T, I put a 4. P is equal to 2 times 4, so P is equal to 8. So you can try the questions on the first part of variation.